Okay, so in the last section, one of the things we talked about was how to calculate the mean from a grouped frequency distribution. And now we're going to talk about how to calculate the standard deviation and the variance from a group frequency distribution. This does get a little complicated, but we're going to go through it because that is going to be involved in one of the things we do for the project. We're going to be setting Excel up to do this calculation for a grouped frequency distribution that we're working with. So here's how you do that. For each class, you need to find the frequency times the midpoint, and we did that when we were calculating the mean. But you also need to find frequency times midpoint squared. That is frequency times midpoint. And you need to add up both of those columns and also the frequency column. And then you use this formula here, n times the sum of frequency times midpoint squared minus the sum of frequency times midpoint squared, divided by n times n minus 1 to get the variance, and then you take the square root of the variance to get the standard deviation. So here's an example that's already worked out. Here's our frequency distribution, and I've added in columns for frequency times midpoint and for frequency times midpoint squared. So in this first row, 11 times 8 is 88, and 11 times 8 squared, now notice that's not 88 squared. We're not squaring the whole thing. We are just squaring the midpoint. So that would be 11 times 8 times 8, and that comes out to be 704. Then 12 times 23 is 276, and 12 times 23 squared, 12 times 23 times 23, is 6,348. So we do that for each row. The frequencies, these numbers, add up to 50. The frequency times midpoint column adds up to 2,290. And the frequency times midpoint squared column, the numbers in this column, add up to 163,490. So when we put those numbers into this formula, the n here and also here is 50. And then the n minus 1 would be 49. 50 minus 1 would be 49. The sum of frequency times midpoint squared, that's the sum total of this column here, that's the 163,490. And then this part of the formula tells us to take the sum of frequency times midpoint and then square that number. So we're taking the 2,290 and squaring that. So notice it's 50 times 163,490 minus 2,290 squared on top over 50 times 49 on the bottom. Now, when you actually put this into a calculator, you will need to put parentheses around the entire numerator and around the entire denominator, because it's this whole thing on top divided by this whole thing on the bottom. So here's what this looks like going into the calculator. I would put it in as parentheses 50 times 163,490 minus 2,290 squared, close parentheses, so parentheses around the thing on top, divided by parenthesis 50 times 49, close parentheses, so parentheses around the entire denominator. And then when I hit equals or enter, it comes out as 1,196.08 and so on. So that number right there is the variance. And then when I take the square root of that number, so I'm asking it to take the square root of the answer to the previous calculation, I get 34.5844 and so on, but rounded to one place after the decimal. We got a 34.5 with an 8 after it, so this gets rounded up to a 6, and I say that the standard deviation is 34.6. So now let's try working through this with this one. If you think you know what to do, you could stop right now and try working through the whole thing and see if you get the same thing I do. If you're not sure, you could take it a step at a time and pause the video to do a step and then see what I did. Pause it and do the next step, see if it agrees with what I did, and work through it step by step. But you'll learn better if you try to think through this and work through it together with me instead of just sitting back and watching me do it. So this is the same frequency distribution that we've seen before in some of the other examples, but this time we're going to find the standard deviation using the procedure that we've just been talking about. So, if you still have your notes from the last section, in that last section, when we calculated the mean, we already made a column for frequency times midpoint and filled in that column. 7 times 3 was 21, 9 times 8 was 72, 13 times 13 was 169, and so on. So that column added up to 485, and the frequency column added up to 40. Now, for what we're doing now, we're going to need one more column for frequency times midpoint squared. And the first number for this top row, when we take this frequency times this midpoint squared, can you see what number that's going to be? Or can you work it out on your calculator? 7 times 3 squared, that is 7 times 9, should be 63. Notice we're not taking the 21 and squaring that. We're taking the 7 times, and then the 3 gets squared. So 7 times 3 squared, 7 times 9, is 63. Now for the next one, it's 9 times 8 squared. And we can put that into a calculator like this, 9 times 8 squared. It will do that correctly. It will do squaring of just the 8 and then the multiplication, and it will be 576. So 576 goes here, and then we do the rest of these the same way. 13 times 13 squared is 2,197. 7 times 18 squared is 2,268. 3 times 23 squared is 1,587, and 1 times 28 squared is 784. And now we have to add up these numbers. So these numbers in this column add up to a total of 7,475. Now we're ready to start sticking numbers into that formula. The formula for the variance, and then once we get the variance, we'll take the square root to get the standard deviation. But for the variance, here's the formula. So what number goes right here for in? 40. What number goes here? This part of the formula, the sum of frequency times midpoint squared? 7475. That's the sum of the frequency times midpoint squared column. And what number goes here? Well, the sum of frequency times midpoint is 485, and then that number is going to get squared as part of the formula. Now, what about down here? We've got in, which is still 40, times in minus 1, which is 39. And now, go ahead and calculate this on your calculator and make sure you get the same thing I do. So this is parenthesis 40 times 7475 minus 485 squared, close parentheses. So there's the numerator, divided by parenthesis 40 times 39, close parentheses. And that came out to be 40.8814 and so on. So that's the variance. And then as long as I've got it here, let me go ahead and take the square root of that number to get my standard deviation. So rounded to one place after the decimal point, 6.4. So the variance, the S squared, was 40.88 something, and the standard deviation, the S, was 6.4. Okay, one last thing, and this is kind of a bonus topic. I'm not going to insist that you know this. If I put this on a test, it will be a bonus problem. But there is something called Chebyshev's theorem that I'm going to tell you briefly what it says. Now, this is about, well, it relates to standard deviation. Standard deviation gives you an idea of how much variability there is in your data. And the idea behind Chebyshev's theorem is that you can't have too many data values that are too far away from the average, the mean of all the data values. And Chebyshev's theorem puts a limit on how many and how far is too many and too far. So Chebyshev's theorem says that in any set of data, you can take any set of numbers whatsoever, make up any set of numbers at all, at least 3/4 of the data values, at least 75% of them, will fall within 2 standard deviations of the mean. Like if there are 40 numbers, at least 30 of them, usually more, maybe even all of them, but at least 30 of them out of the 40 will fall within 2 standard deviations of the mean. That is, they can't be more than 2 times the standard deviation away from the mean in either direction. So between the mean minus 2 times the standard deviation and the mean plus 2 times the standard deviation. And then there's other parts to the theorem. At least 8/9 of the values are guaranteed to be within 3 standard deviations of the mean. At least 15/16 of the values are within 4 standard deviations of the mean, and so on. The general pattern here is that this fraction has a perfect square on the bottom, and then 1 minus that perfect square on the top. So like 2 squared is 4, 3 squared is 9, 4 squared is 16. So that tells you how many standard deviations we're talking about. At least 1 minus 1 over k squared of the values in any set of data at all. At least that many of them, usually more, but at least that many of them will fall within k standard deviations of the mean. So for example, if you have a set of data whose mean is 50 and whose standard deviation is 4, well, that would mean that 2 standard deviations would be 8. 2 times 4 is 8. So being within 2 standard deviations of the mean means being within 8 points of 50. Between 50 minus 8, which is 42, and 50 plus 8, which is 58. So you're absolutely guaranteed to have at least 3/4 of your data values, maybe more than that, but at least 3/4 of them between 42 and 58. There can't be very many of them that fall outside that range. And at least 8/9 of them are within 3 standard deviations of the mean. 3 standard deviations here in this example would be 3 times 4, which would be 12. And so being within 3 standard deviations of the mean means being within 12 points either way of 50. So 50 minus 12 is 38. 50 plus 12 is 62.